On this episode of This Week in Space, we visit with Dr. Pascal Lee, founder of the Haughton-Mars Project, to discuss the recently completed 2022 field campaign on Devon Island in the high Arctic.
Podcasts you love.
From people you trust.
This is TWiT.
This is This Week in Space, episode number 34, recorded October 21st, 2022, Mars on Earth. This episode of This Week in Space is brought to you by Wealthfront. Visit wealthfront.com/twit to get started and get your free $50 bonus with an initial deposit of just $500. That's wealthfront.com/twit. Hello and welcome to another episode of This Week in Space, the Mars on Earth edition. I'm Rod Pyle, editor-in-chief, Van Aster Magazine. I'm joined by the indisputable Tariq Malik, editor-in-chief at space.com. Good day, Tariq.
Hello. Welcome all.
Today we're going to be talking once again with planetary scientist Pascal Lee. Pascal founded the Mars Institute and the Haughton-Mars Project in the 1990s and has been operating the Haughton-Mars Project's Mars analog base on Devon Island, which I had the good fortune to visit this year, up in the high Arctic since 1998. We recently returned there from the 2022 field season, which was the first visit since 2019. So we're going to talk about that a bit today and some other things. So Pascal, thanks for joining us. How are you?
Hey, I'm delighted to be here, guys. Thank you.
Hello, well, repeat guest. Woo!
Woohoo! It's always great to have you, and thanks for being our first repeat. Before we embark,
better people to invite, but okay, thank you for having me.
Oh, now don't be so humble. There's nobody better than you. Before we embark on our journey to Mars on Earth, we have a joke. This one from a mutual friend of Pascal's and mine, Melissa Silva from Tucson, Arizona. Hey, Tariq.
Yes, Rod?
How is the Mars Opportunity rover like the Space Launch System?
Wait, I'm laughing already. How is the Opportunity rover like the SLS, the Space Launch System there?
It was meant to be gone in 90 days, but we may still be watching it drive around 14 years later. Oh,
ouch. I'm gonna come in and say it's been 18 years since the big rocket was first envisioned. So it's got opportunity beat now, but okay, we'll talk more on that later.
That's a good point. Yeah, as long as we're talking records. All right. Well, that was a pretty good one, actually. Thank you.
It was good. It was good. You got the first shot. Congrats.
I know it's very rare. Just a reminder: we are opening up our comms for space jokes. So if you're interested, give us your best shot. We did get a few in, which are in the queue now. You can send them to twis@twit.tv. That's twis@twit.tv. Each week, we'll pick one or two of the best ones and read them on the air with credit to you. And that's it. No fortune, just fame. All right. Let's get to some headlines and then on to the interview. Big sigh, as long as we're talking about it. Artemis update. Mr. Malik.
Yeah. I don't have much to report on the Artemis front aside from the fact that it's still in the barn at the Vehicle Assembly Building in Florida. Now, that was the plan. Now, NASA's not expecting to roll the SLS out to Pad 39B until November 4th. Now, with this new target of November 14th, I did talk to the NASA folks earlier this week just to kind of check in. They said that they are really looking forward to the 14th and not the 16th or the 19th or any other window after that November thing. So the big update is I now have a family conflict, and so I can't go to that November 14th window. We'll be sending editor Brett Tingley instead. So,
it must be
Can
so
I
awful
go for
to
you,
have
Tariq?
It must be so awful to have a travel budget.
Of the SLS, yeah.
Yeah. Okay.
Well, I will be sad to miss it, but hopefully Artemis 2, if everything goes. So they could delay it again. Who knows, right? So.
Cry me a river, you overfunded journalist. All right, next up, Space in a Bottle from space.com, our dear friends. An 18-year-old kid named Christopher Slayton replicated the major features of the known universe in Minecraft. I saw this story. I don't know, it gave me the giggles in a good way. I mean, I didn't think it was silly. I thought it was great. He started with the sun and planets. Saturn's rings were particularly challenging, he said, because when things are at an angle in Minecraft, I guess you have to build them like stairs. Finished the other planets, then created galaxies, galactic clusters, the Pillars of Creation Nebula. Try that with Lego. And a black hole. He finished up with a representation of the known universe and its structure. There's a cool video on YouTube that documents his process. Apparently, Minecraft is not ideally suited to this task, due in part I guess, to the fact that you have to sort of, if I understand it correctly, hand paint in the lighting effects. Boy, do I sound like a boomer or what? Well, I understand it correctly. It's little bricks. It took him more than 2 months of full-time work. Future project plans include modeling the fourth dimension and the multiverse. That's going to be interesting. So I wish him luck.
Yeah.
It'd be a real shame if he just vanished one afternoon while he was doing the multiverse, wouldn't it?
Oh no. No, this is a really great story. It shows that connection between kind of a new generation of space fans, games, and how they're expressing all their passion in the mediums that are really comfortable. My daughter plays Minecraft, not at this level. She usually plays with her friends, like, hunting animals or whatever. But this just takes it and it turns it into art, and it kind of harkens back to the start and the launch of Minecraft, where people were creating things like the moon or even the Starship Enterprise. I saw it one time in Minecraft, but I mean, he's using Chris Slayton, like the latest renderings of these planets, and just the way that he made the pillars of creation, not in 2D, it's like 3D models. He recreated it one block at a time with these, using all the different mods and stuff that Minecraft allows. Is pretty great. So.
And
everyone should watch the YouTube video. The YouTube video is really cool. So
and he definitely has a future as a video producer as well, if he actually shot and edited that thing.
That's right.
All right. Hey, Tariq, it's been a tough week over at SpaceX. What's going on?
Yeah, kind of a weird one this week for SpaceX, largely driven initially by Elon Musk. Last week, there was a lot of back and forth with Elon complaining on Twitter about the cost of Starlink in Ukraine. This is the same Elon Musk who 6 months ago or so answered a call from Ukrainian officials to donate Starlink terminals and service to folks there because of the Russian invasion. And there were reports, first out of CNN and then from others, that SpaceX had approached the military to ask them to start covering the cost. That it's costing them $20 million a month or so, $120 million by the end of 2022 alone to provide this service gratis. Now, this is because they've been providing the Starlink terminals, I think something like 25,000 or so by this point in the year, and offering the service for free. Over the weekend, Elon said, all right, to hell with it. We will just keep eating the money and providing the service to Ukraine that they said that they were going to do. The Pentagon said that they're not covering any costs, but they're looking into ways to keep the service going. And SpaceX has been working. They worked with USAID. They worked with some other groups to use donations and whatnot to keep Starlink thing. So it's really just a really weird and not a great look for SpaceX this week, and Elon Musk in particular, about this tiff over a service that they seemed pretty adamant to provide back in February when the invasion was just starting. Now they're starting to kind of bristle at the cost of it. And it is an expensive system. It's like $600 to set up, $100 plus $110 a month. Just for the commercial side, it's more expensive for different types of services if you're using ships or planes, that kind of thing. That was one story. The other story, and this came out of both Business Insider and a site called Semaphore, where it turns out that SpaceX was fined upwards of $18,000 for two different safety violations related to an accident in which a technician was injured while servicing a Raptor 2 engine. That's the engine for the Starship rockets, right? They're going to use 33 of those on the Super Heavy, 6 on the Starship itself. And this technician, pardon me, we believe his name is Francisco Cabada, according to Business Insider, was working on one of these engines at the factory. They were using a new automated kind of testing for it, and a fuel, I believe, I'm going to make sure I got it right here, a fuel controller cover broke free and hit him, basically put him in a coma. He's out of that coma now, but still on like assisted life support and whatnot. He can't communicate. A really weird thing to have happened at a company that's known for its relative efficiency. And SpaceX, we reached out for them for comment, and we didn't hear back. Neither did the Business Insider or Semaphore. So, it's a very strange incident that has happened there, and we're hoping to learn a little bit more about like what went wrong in that service, because we've never heard of these kinds of accidents in that factory at all. And they need a lot of these engines for their Starship program.
Well, hats off to Elon for providing Starlink in the first place. I guess if I have any sympathy for him in this particular story, it's that nobody, I don't think, really expected this war to go on this long. We thought there would be a conclusion by now. So, yeah, it'd be interesting to find out how much of that is actual hard cost and how much is lost revenue. But I guess
and they did just launch a new batch of 54 satellites this week, and there's bound to be another Starlink launch next week. They're launching weekly now.
That's exciting. And finally, one I like to call Look Out Below. This is from space.com and other outlets. This morning, Friday morning, was the theoretical peak of the Orionid's meteor shower, which is one of the best yearly displays of fire in the sky. But don't fret. Tonight, tomorrow morning should look just fine. You'll have to go somewhere very dark as possible, to see them well. And you can expect maybe 8 to 10 very bright, fast-moving meteors per hour. If you've never done it, it's exciting. Now, don't hear me when I say 8 to 10 per hour. You're not out there unless you see the Leonids in 1966, like I did as a very, very young man. You're not going to see what you'd see in the movies. It's not, meteors happening every second, but it is a beautiful way to spend an evening, better after midnight for most showers. To find a dark spot near you, go to darksky.org. That's darksky, spelled just like it sounds, .org. We'll put the website in the show notes. And look at the global map of dark places. It doesn't cover everywhere, but it covers most of the U.S., Latin America, and Europe. Personally, I'll be driving out the California high desert, which at this point, by the time you lose the light from Los Angeles, you're starting to pick up the light from Phoenix. But, we do the best we can. And I'll check it out.
That's a good place. Yeah, I just want to point out that the Orionid meteor shower are leftover bits of Halley's Comet. So if you do happen to see some, that's the origin story for that. And it'll appear to radiate out of the Orion constellation. That's why it's called the Orionids. Orion is really easy to find. It's a really well-recognized star pattern up in the southeastern sky. But you don't have to look in that spot. You just look straight up. You'll see the meteors. So.
That's right. They appear to radiate from there, right?
That's right.
But they go all over the night sky. So as long as you're looking up, you're in good shape. All right. We will be back to talk to Dr. Lee after this short message, so stay with us. This episode of This Week in Space is brought to you by Wealthfront. Wealthfront's goal is to make building long-term wealth easy, offering both high-yield savings and automated investing accounts that do just that, all within a beautifully designed interface. Is your bank keeping money that could be yours? If you're earning less than Wealthfront's 2.55% annual percent yield, they just might be. Here's why. Federal interest rates have been going up this year, which means banks have been earning more in your savings. Where's all that extra money going? According to the FDIC, the average U.S. bank has only raised their rates to 0.17% this year, while Wealthfront is now offering their clients a rate that's about 15 times higher with the Wealthfront cash account. Don't let your bank keep the interest you could be earning. Join nearly 500,000 people who already use Wealthfront to earn 15 times more than the average U.S. bank. It's easy to sign up, plus you'll get unlimited transfers that are completely fee-free and up to $1 million in FDIC insurance through partner banks. There are no account fees, no minimum balance, and if you sign up at wealthfront.com/twit, you get a free $50 bonus with an initial deposit of just $500. Visit wealthfront.com/twit to get started and get your free $50 bonus with an initial deposit of just $500. That's wealthfront.com/twit. This has been a paid endorsement for Wealthfront. Pascal, thanks for coming on today. We appreciate it. I know you're a busy man. I can see you're looking down. You're working on a proposal as we speak, I think. Is that what you're doing?
Just try to be efficient, yeah.
Efficiency is your middle name, unless you're looking at Mars photos, in which case you get completely lost, because I've seen that. All right, so let's recap, since we haven't had you on for a while. Who are you? What do you do? Why are you important? Why are you awesome?
Really, and these are good questions. But
you're asking them yourself, are you?
I'm a planetary scientist. I study mostly Mars and for the past few years, the moon as well. I also am a big advocate and fan of humans going to Mars as soon as possible. Obviously, at this point, after we return to the moon, but because I think that our knowledge and understanding of Mars will really explode once we get humans there. And so every robotic step that we take that somehow is not in preparation for humans going there is in my view, a suboptimal opportunity.
Okay, JPL, are you listening? I understand. I was at a Mars Society conference years ago with one of the top dogs from the Curiosity rover program, and we were chatting, and he saw a group of people headed towards him, and he said, will you stay here with me for a few minutes? And I said, sure. He needs the cover. And he said, yeah, these people get pretty upset about robotic programs. So I understand the sentiment, but at the same time,
don't get me wrong.
I'm a firm believer that robots will always go first to the dark and scary places.
I'm totally a fan of robotics and robotic missions. I just think that we should spend more of their agenda on planning human missions, landing site selection, things like scouting out places where humans could go in a more sort of systematic way than we do.
Yeah, which might argue for smaller, less expensive, more expendable rover designs in the future to go to some of those places like you've advocated, lava pits and so forth.
Yes.
Yeah.
I mean, I'm totally driven by the science of the place. In fact, I think that's, from my perspective, the most exciting things for humans to do there, which is to look for possible signs of extant life that might still be alive. And I tend to have the view that at this point, since we are at the threshold of sending humans to Mars, we should really dedicate our robotic efforts. We should dedicate a larger part of our robotic efforts in human exploration recon activities. We should map all the ice on Mars with an orbital ice mapper, which somehow was axed now from NASA's upcoming agenda for Mars. We should like you said, have a swarm of cheaper robots check out, however, a larger number of potential landing sites for humans and things like that. Yeah, the science we can, we get good science back, of course, from each robotic mission. Has a lot of instruments on them for science, but we should be focusing on getting humans there at this point, so that our knowledge will then explode about Mars and not piecemeal it at this point.
Well, yeah, and to that point, Pascal, you mentioned about being on the threshold of sending people to Mars, hopefully back to the moon, in the next few years.
Yep.
That's what it seems like. You and your team in the summer of 2022, you took Rod with you, and I'm sad that you didn't leave.
And he's still regretting it. Oh!
But you went to this really remote. I love you, Rod. I love you. I'm glad you came.
Yeah.
You went to this remote place that on I think it's Devon Island. Is that correct? Right?
Yes, Devon Island.
And you've got this habitat there for the Haghton-Mars Project. Can you let us, what is that? Why did you go to that extreme place? Because we're here to talk about trying to get ready for Mars on Earth. And how do you do that at this place? Can you give us a snapshot of what this place is that you went to?
Yeah. Well, having Rod with us was an experiment in itself that we conducted. But seriously, Devon Island, why Devon Island? Well, Devon Island is about the size of West Virginia, and it is the largest uninhabited island on Earth. Now, that's not why we go, but that's just telling you how desolate and barren the place probably is. It's located at 75 degrees north, so about 1,000 miles from the North Pole. It's in the eastern Arctic, which means that the climate there is not only cold, but it's also dry. It does rain a little bit in the summer, but in terms of liquid water precipitation and water that is, put into the ground each year, we're dealing with a desert. In fact, it's what's called on Earth a polar desert. And Mars is a polar desert by terrestrial definition. It's cold and dry and desolate and barren. Now, on top of that, Devon Island has a large, very well-preserved meteorite impact crater called Haughton Crater, Haughton. Haughton is 20 kilometers in diameter. We all love Meteor Crater in Arizona. Meteor Crater in Arizona is about 1.2 kilometers in diameter, 0.8 miles. This thing is a whopper compared to that. It's 20 kilometers in diameter, approximately 15 miles. It formed relatively recently, 23 million years ago. I mean, that's not long ago, geologically speaking. And so you have a very well preserved impact crater. In fact, if the place was smoldering still, it would look like it just formed. But other than that, everything is still very well preserved. And so all of a sudden, if you describe this place, you have a barren, cold, dry desert that's rocky, unvegetated, UV drenched, laced with ground ice, scarred by impact. You just described Mars, but you just described Devon Island as well. Mm-hmm. And so, at a very basic level, of course, none of this is as extreme as Mars. Mars has zillions of craters. Mars has a different gravity. Mars has, cold temperatures that are much colder than this. But it's a step in the right direction. It's an analog. And sometimes people misunderstand, I think, the word analog. It doesn't mean that the thing is the same as Mars. It's a Mars analog, meaning that I tend to think of an analog as something that's relevant. It's not the same, it's just that it's relevant. And so by going to a place like Devon Island, you enter a part of the Earth that starts to present some features that we think we recognize on Mars and might be here on Devon for the same reason as they are on Mars, because we're heading a step in the right direction. So it's relevant to Mars.
So I'd like to ask a question about analogs, because I think it could use a little clarification. So there's Mars analogs like yours, and then there are others, many more others, that are more experiential in nature. So I guess the way I look at it, and feel free to correct me if you think I got this wrong, is with something like the Haughton-Mars Project, your project, you have a facility that has lower fidelity in terms of the personnel process experientially, but a higher science return, whereas there are other facilities, including on Devon, that have a higher personal experience fidelity, but in my opinion are lower in science return. Do you think that's a fair characterization?
Yeah, well, to your point, I agree. We have to really understand the term analog more broadly. I mean, you can have an analog in a lab for one thing. You could have a chamber where you create a vacuum in very cold temperatures and you simulate the Martian pressure temperature conditions. That's an analog as well. In fact, people who do spectroscopy, who acquire spectra of Mars and then compare that with the spectra of terrestrial rocks, that's actually an analog study as well. You're comparing the wiggles in the spectra of Mars rocks compared to the wiggles from spectra of Earth rocks. It's a comparison of wiggles. And so that's what spectroscopy is. It's also an analog, approach. In fact, it's a very general approach in how humans understand the world around them. They compare what they see with things that they've seen before, more or less. But to your point, we don't do simulations on Devon Island very much. We're not there to pretend we are on Mars and, work as a crew in that same, simulation sense. We're there to do field work in the Arctic. And some of our experiments entail, aspects of a simulation. For example, when we test a spacesuit, obviously we do a simulated EVA to the extent where we hike around with the suit. In the suit, we have comms. We are, simulating a very limited and specific portion of a Mars or Moon exploration mission. But we're not, at the same time cooping up the crew in sort of close quarters to look at their group psychology. First of all, mainly because that's been done a zillion times elsewhere, and we have a lot of experience with that already. But the other thing is that full-up simulations, unless they're really done well with the full gamut of the simulation backdrop, with delayed comms, with mission control, and having people who are actually remote supporting you the best they can, having all kinds of other elements of the simulation being in place, they you don't want to cheapen the currency of the word simulation. Okay, and so some of the work we do are simulations, but they tend to be very limited in scope. And then the rest of the time, we are just examining how we ourselves explore this place. How do we study it scientifically? Is it better to go out in teams of 5 or 4? How do you work? How do you manage the sample collection when you're just 3 people or 2? And we look at how we optimize our fieldwork here on Earth, and then think through how this could be adapted or optimized for the Moon or Mars down the road. And so it's a different approach, and it's been proving to be, in my view, very, very productive, because you really get to analyze why you do things. You really get to analyze why you do things. For example, you often hear that somehow the most important thing for geology to be done on the Moon to collect samples is to maximize EVA time. You want to maximize boots on the ground time. Okay. Well, that's because that's how the Apollo missions optimized their return. Okay, at the time, there was mostly footwork, and then you couldn't go so far that you couldn't be able to walk back to your lunar module. So by definition, you were within walking distance of your lunar module. There was a lot of emphasis on boots on the ground, but boots on the ground wearing a heavy spacesuit, that's not optimal. And what really matters in doing field work, for example, is eyes on as many rocks as possible on the ground time. It's not really boots. And if you realize that, then you realize that if you have a pressurized rover, for example, that affords very good visibility and a lot of mobility and flexibility and nimbleness for you to collect samples through a series of screens or windows, then you are actually doing optimal field geology. You are able to see rocks, because that's really what is essential, is for you to perceive the landscape, collect samples that you see. Whether or not you're doing that on with boots or wheels or robotic arms or directly with your hands in a glove, that is immaterial. And so it's the type of lessons that we're trying to convey, so that in the way we design our pressurized rover, for example, we make sure that we will have helmet bubbles essentially sticking off the sides and the front of the rover, so that we can actually do a lot of eyes on the ground time when we're driving around.
I was going to say, it sounds like you want to just go off-roading on Mars there, Pascal, instead of So walk me through. So you mentioned that you've got this great crater at Devon Island, the Haughton crater, very pristine, very desolate, very Mars-like area. It took me I think 30 different visits to pick where I wanted to live in New Jersey, right? When did you work to set up?
Which exit?
Exit 10, right? I shouldn't be saying that. I shouldn't be saying that out loud, right? Now people can find me. But what do you have there to live in, right? How do you pick where you're going to live? What do you take there, right? I imagine you have a habitat of some sort, some way to move around when you and Rod are out exploring and your team. What is it like to live there on a basis? I mean, I would imagine just getting there is a bit of a slog, right? I mean, it sounds like a pretty remote place. Oh, yeah. Rod sounds like. Should I ask Rod?
4 days of flights. Yeah.
You don't stumble or end up on Devon Island. You sort of have to really intend to go there, because there's really there's a lot of things that have to line up for that to happen. But there's a logistical path. I mean, you fly regular airline. First of all, the first place where we all gather as a team is usually Ottawa in Canada. And that's because Ottawa is, beyond being the capital of Canada, it's actually the launching place for jetliners to go up the Eastern Arctic route. And so we fly on to the Eastern Arctic, to Iqaluit, which is the capital of the territory of Nunavut, which is where Devon Island is part of. And then from there, we fly on, still on a regular airliner, to Resolute Bay, which is a small community in a separate island. And then usually you stay in Resolute for a day or two, waiting for your own plane to be available, for the weather to get better. And then you charter your own plane to go to Devon Island, where we have a dirt strip. And yes, where we've set up a camp, which has grown over time just to meet our needs and the scale of our research, which is sort of another aspect that's really interesting. There are many analog projects that are supported by NASA now, but this, I think, remains the only one where an infrastructure was really set up that was permanent or semi-permanent. We've been operating this base, like Rod said, since last century, since 1997, and you learn a lot of lessons about how to set up your base. How do you use your space? Do you concentrate activities that are similar in one place, or do you distribute them? And that's going to depend on the type of activity. I mean, a simple lesson that we've learned, that I often share is there's never enough storage space in a base. There's never enough storage space. And this is something that, of course, we've run into the space station. You look at the inside of the space station and there's stuff all over the place. That's not even a new lesson. Skylab was a lot more organized that way, but somehow something got lost in translation there when the space station was designed, and the inside of the space station could really use some storage space for stuff. Our base is sort of the same thing, and you need a lot of things on a base that you may use rarely, but that really should be there. Beyond the supplies, we have emergency food supplies, we have emergency medical supplies. There's also emergency medical equipment, but we also have scientific instruments that you don't need necessarily every day, and they have to be properly stowed. And then of course spare parts for vehicles, spare parts for tools, all the key things that we need, we have in spares. And so that actually creates a real need, and it tends to be underestimated when people design bases. I actually spent a year of my life in a base in Antarctica back in 1988. I was doing my national service for France at the time, and I was, a station scientist at that base for 402 days. And I remember, we had so much stuff that needed to be stored, and it was, that actually wasn't too bad. It was pretty well managed, but it was just a lot of stuff. And that experience actually taught me a few things about how a base in the Arctic that we were going to build ourselves at this site should be organized or set up. So, for example, we've adopted a star-shaped pattern, which minimizes the amount of walking that you have to do to go from one satellite module to another, and the traffic, is often ends up in the core hub of the base. Which is also a social area and a place where we end up, having our meals together now. So there's a logic and a flow to designing a base that you don't understand the importance of until you really have to design it yourself, and it's really meeting a need. And so these are the types of lessons that I hope are being captured or will be conveyed or understood by those who are planning, an Artemis base camp or Moon Village.
So you have like a hub where everyone eats and sleeps, and then like a hub which is like the science hub and a greenhouse or stuff like that, like arranged in a star shape. That's what you're saying. Okay.
Yeah, the hub is not where people sleep though. It's just where we eat and where we gather for meetings and where we have our social life. Every module, including the hub, also is used for storage. That's the other aspect. It's sort of a second function of every habitat. And then we have, like you said, dedicated science modules, but also a workshop, garage, but also an office, which is sort of the command center. Rod had his office with us in the command center. We that way we could pour over maps together, plan our traverses, and he could also write his
his dispatches to
chronicle.
space.com. That's right. That's
Yeah,
right. His
yeah.
month on
Those were
Mars.
awesome.
Everyone, thank you for
Those
doing
were
that.
awesome.
We had a great time.
Yeah, people haven't read those. They're really awesome. I've rarely had anybody capture so nicely and so in such a sort of a resonating way with the team on site, the experience that we were having doing a field campaign. Okay, so Rod really did a great job with that. And those of you who don't know what we're talking about, he wrote a series of chronicles or briefings from the field, which were carried by space.com this past summer, and they were really, really good.
Aw, shucks, you guys, you caused me to blush. Yeah, I've found that the larger I get, the more I resonate. So that's a good thing. So I have a question that I'm going to ask next. I want to hear about your impressions of this year's field campaign. But before we do that, we need to take a short break. So stay with us. So as you said, we did document some of the things we did in the dispatches that I was able to turn out, but those were, real time as it was happening next day sort of things. And none of us had a chance to really reflect on what was going on. So now that you've been back for a couple of months, can you just give us sort of a rundown of the results of this year's field campaign and some of the things that came out of it?
Yeah, well, so this year was the first time we went back, like you said, in 3 years. We skipped 2 summers, the 2 summers of COVID. There's a summer of love and there's a summer of COVID. Okay, so the 2 summers of COVID were 2020 and 2021. We went to Oregon in 2021 because we couldn't stand it anymore, so to speak, to not have a summer field campaign and continue our work. But this was our first time back in 3 years, and I was very happy so one of the key goals this year was to assess the state of camp, and we were very happy to see that the camp was still up, operational, operable. And, while there was some damage from the winds, from the snow, from the elements on some tent fabrics, overall the tent was in good shape. We have rigid structures and also tent structures, and over time, by the way, we'd like to replace these tent structures with more permanent structures. And so I'm actually trying to fundraise here very soon, and on the lookout for some new options for rejuvenating some of our tents and replacing them with solid structures. But anyway,
well, if I may say, just so people understand, this isn't a tent like you go down and buy at Big Five. It's not a Coleman, thin nylon tent. These are semi-rigid structures that look like Quonset huts. They're arched with aluminum frames and then a thick insulated layer of tent with batting inside. So they're fairly expensive.
Yeah, I mean it's typically $20K a tent, and $25 to $30K by the time you've shipped it up to the Arctic.
Okay, so
but
send
anyway,
those cards and letters and donations in. Okay, sorry, go ahead.
Yeah, incidentally, we're interested in naming some of these tents that we're going to buy here in the future after folks who will help us, or companies who will help us acquire them. So if you want your company logo on one of our base camp tents, that's the beauty of having a privately operated polar research base. We can do things like that quite flexibly. But to your point, Rod, we assessing the camp, that was in good shape. And then, of course, we had like every year, we have a science program and an exploration program. The science program this year consisted in us going out to collect samples of impact melt, rocks that were actually melted by the impact at this location. We wanted also samples of some of the salts that were deposited, because as soon as the impact crater formed 23 million years ago, there were hot springs going around the crater especially, but also inside. And these hot springs, unlike volcanic hot springs, which can last for centuries to millennia, these hot springs are very short-lived because the impact dumps a big pulse of heat into the ground, and then eventually things just cool off. And so these are short-lived hydrothermal events, but it's very similar to what might have happened on Mars with so many impacts on Mars. You had plenty of water on Mars, mostly in the form of ice. An impact happens, all of a sudden you have a pool of water and some hydrothermal vents going, hot springs. Could that be sufficient with many impacts happening across the planet? Could that be sufficient to somehow allow life to sort of eke a living and evolve? So anyway, I digress. We had some hydrothermal samples to collect, so quite a bit of sampling. We are also looking for tardigrades on Devon Island. Tardigrades are these little critters.
Water bears. Yeah.
Water bears, exactly. That are incredibly, that sort of have a sort of it's a spacefaring type of adaptation. They are very resilient to low temperatures, to low pressure, to high temperatures as well, to the vacuum. Although they don't like that too much, they tend to just mothball when that happens. But they're very hardy little creatures, and we are in the process of inventorying all the extremophiles that exist on Devon Island, for as a baseline for our studies. And so tardigrades were on our hit list this year. And so I was collecting a bunch of soil samples, moss samples, lichen samples to see if tardigrades might be associated with these little patches of life. So that's the science. The exploration part, that was actually pretty beefy this year. We had some spacesuit tests. We were also operating a drone, and we've been interested in drones since 2015 as a tool for Moon and Mars exploration. Obviously, on the Moon, you wouldn't fly a drone with rotors. You would fly it with rocket thrusters, little jet thrusters. But for Mars, a drone would be, as demonstrated by JPL's Ingenuity helicopter, it's a formidable and beautiful tool for exploration. But we are interested in how drones could be used in the context of humans being there as a sort of a robotic assistant to humans. And as it turns out, drones have some really good attributes. Obviously, you could use them for scouting ahead of you for a traverse that you want to carry out. Because orbital scouting, orbital reconnaissance to plan a traverse is of course very important. You get that big picture, but you can't sometimes see a 1 meter drop, or a 5 foot drop in the terrain if it's vertical, and you can't necessarily see that from orbit. And so if you run up against something like this with your surface vehicle, you're going to really be in trouble. So we really want to do some drone reconnaissance as much as we can for this traversing unknown terrain, unknown rough terrain on Mars in the future.
And Pascal, is that like a little drone that like my daughter might fly with her phone, or are these like bigger, kind of more industrial drones that you need a special control thing?
It's sort of a medium class type drone. It's a drone where we don't kill the budget of the project if we crash it. Yeah. But at the same time, it's a drone that's sophisticated enough that it has some features that are optional, so that you can fly it in the Arctic very close to the North Magnetic Pole. Okay. Drones that we normally have are not very happy without a magnetic field being present, or if the magnetic field is not behaving normally, because it doesn't just use a GPS, a drone, it also uses the Earth magnetic field and a compass on board to figure out which way to go. So flying a drone of a sort of a regular commercial kind down south is relatively easy to do if you leave it in GPS mode, so to speak. Mm-hmm. But it's still using the magnetic compass when it's in GPS mode. Whereas if you go to the Arctic, you're so close to the North Magnetic Pole that it can no longer understand the North Magnetic Field the magnetic field situation very well. Your magnetic field lines are pointing to the ground. It's basically telling you are there. It's okay at the pole.
Well, yeah, I was gonna ask. I mean, this sounds like a really like you got your money's worth on the trip to make sure that everything was good. You got the exploration in. You did your spacesuit tests. Rod told me that you had to prepare for polar bears there. I mean, that's something that people on Mars aren't gonna have to deal with. But you're up there in the Arctic. Do you have like a anti-polar bear weapon that you have to train on and make sure that everyone knows how to use?
Polar bears are at the top of the food chain. I bring my dog, which does two things. The dog serves as an advanced alert system for polar bears. He's always on the lookout and is very good at spotting things. We don't expect the dog to attack a polar bear, of course, or even vice versa. We expect the dog to distract the polar bear in case the polar bear shows up at camp and we need to scramble for our shotguns.
Pascal, what's your dog's name, Pascal? Your polar bear dog's name?
Apollo.
Of course.
Yeah.
Of course. So
middle name program. Apollo. He's 4 years old. He's an Australian cattle dog. So he's in his element in the desert. It's just not a polar desert. So he's but he's got a thick coat. He's
and true to his breeding, it's great fun to watch. Every time Pascal goes on a walk away from base, Apollo comes running along and nips at his heels and jumps up and barks and herds him. He leaves the rest of us alone for some reason, even though we're all very sweet on him. But Pascal is his sheep. So
Apollo is your polar bear early warning system. And then what else do you have to do to prepare
and the pack alpha, by the way.
we have shotguns. And then we have people who we think won't run as fast as you do. So
here. Yeah.
So that's our polar bear protection system.
Well, and let me just add, the shotguns are loaded first with the equivalent of a small flashbang. So there is a warning. This isn't hunting season on polar bears. This is okay. You carry the shotgun as an absolute last resort. There's a warning shot and then, the lethal one. So every measure is taken to try and distract or dissuade them before doing any harm. Yeah.
And did you see any on this trip?
Not on this trip. We saw Arctic fox, which we normally don't see. So we saw there are a couple sightings of Arctic foxes this summer. Rod actually, since he had some expertise with prior expertise with shotguns and guns in general, became our gun master basically at camp and on traverses.
Rod.
So
I've been outed. Yeah.
So
we did see evidence of polar bears, however, when we got out to the pink Humvee.
Oh yeah, they're around. You see tracks, and yeah, for sure they're around.
Well,
yeah. So
not just tracks, but your door was bent back. That was polar bear damage, wasn't it?
Yeah, it's a Kevlar armored door for the Humvee, and it was the metal was bent. I mean, the material was bent from claws. Yeah, so polar bears are a real issue, and of course, like you said, we don't have to worry about that on Mars. But
so that we know of now, right? So
that we know for now, yeah. Where was I? But it's a constant safety issue, and it's something that we really address seriously. So we have people on the lookout every time we are stationary somewhere. I mean, while someone is busy collecting a sample, somebody else is keeping an eye on the horizon. And because polar bears are super smart, and they have personalities, and they have a general behavior and pattern, but they also have individual initiative, and they don't necessarily behave in a sort of a necessarily standard way each time. So you have to. You're dealing with something that's, like I said, super smart and an apex predator. so you want to be on the lookout for polar bears. Well, I just wanted to add one thing about the drones thing earlier. Scouting is one thing, but one of the important uses, I think, of drones in the future will be to collect samples from places that are biologically sensitive. NASA has this list of this growing list of places that are considered to be biologically sensitive, special regions they're called. They're the places that need to be protected, where you don't want to contaminate those places because they might have life, but also you don't want to be contaminated by that life if you run into it. So having drones as a pre-sterilized tool that you essentially unwrap during an EVA launch, or unwraps itself during an EVA launch, and goes collect the sample in an aseptic way and brings it back to some interface where you can then keep the sample out of your direct contact. That's actually a really powerful tool for planetary protection and exploration in the future. So there are all kinds of applications of drones that we're looking into now that could really help with Mars exploration.
So can you talk a little bit about some of your future research goals, both for the Haughton-Mars Project and for yourself personally?
Yeah, well, first of all, it's important to understand that the Haughton-Mars Project is a big team effort. I mean, it's not just my research goals. We have collaborators, co-investigators, and my overall goal is to continue advancing key knowledge in how we should explore Mars, and strategies for Mars exploration and technologies for Mars exploration. And it's not just Mars at this point, it's the moon as well. A lot of the lessons that we're learning from Devon, of course, we do that in the spirit of them advancing Mars exploration, but we would like to try some of these procedures out, some of these technologies out in lunar exploration. I mean, just to pick one example, one of the biggest challenges we face for Mars exploration right now is the weight of the spacesuit. The current spacesuit that we have weighs approximately 300 pounds. And I might have discussed this before here, I don't remember. But if you take the spacesuit to the moon, where gravity is 6 times less, that 300-pound suit has only a felt weight of 50 pounds. So that's manageable, and that's even why the Apollo astronauts were able to do so much good work on foot. You take this same suit to Mars, a 300-pound suit on Mars would have a felt weight of 125 pounds. It's impossible to be really productive doing field work. I mean, you can't really hike up and down an outcrop. You can't bend down, 5 or 6 times an hour to collect rock samples. It's just not practical. Even if you're super fit, I mean, that's just not the way you want to do field work. So we really have a challenge, which is to reduce the mass of the spacesuit by the time we get to Mars. And the spacesuit is already lean and mean in the way it's designed, and that's it. So one way that we think is needed for Mars to reduce the mass of the spacesuit is to offload onto a vehicle that you drive, an unpressurized little ATV, for example. It's to offload some of the heavy stuff that in your backpack you don't have to carry in such a large amount. So, for example, if you had batteries mostly stored on your ATV, and oxygen mostly stored on your ATV, and water mostly stored on your ATV, then you can have a spacesuit with only small oxygen tanks, small water tanks, small batteries. And of course, that's going to limit your time on foot. But then your ATV is also going to be a robotic ATV that follows you. Just like we have suitcases now in airports that follow, their owners. So you can see how the exploration system becomes not just you and your spacesuit, but it's you and your spacesuit and your ATV as a partnership. But that's essential, because even though we're going to reduce the mass of a spacesuit a bit with new materials and new design features, you're not going to cut a mass of a spacesuit in half at this point without offloading some of the stuff, while keeping it handy. And so the concept here is to have ATVs that you ride, and while you're riding them, you can recharge the batteries, the water, and possibly the oxygen down the road as you ride around. And then when you step off of your ATV, you can either stay connected with an umbilical, or you sever your umbilical, but it follows you so that you never really have to walk back that far to get back to your ATV. And of course, in a contingency, your ATV can also carry an extra person, as a contingency situation. But this concept, which I think is really going to be required for Mars, is something that we really should be testing on the moon. And so a good strategy for Moon to Mars would be to precisely go down this road of having rechargeable, life support systems and pair up each astronaut in the future with an LTV that's designed more like an individual one-person ATV. That's my view. That's why I'm trying to convince NASA of looking into, and it's sometimes hard to sort of change minds on this, So that's all I can say.
So for 2023, then, I mean, you just got back from the campaign. I mean, are you already mapping out what you're going to be doing in the summer of 2023 there, or is there more work and then you'll punt to 2024? Or?
We're only starting now to map out what we might be doing next year. I mean, we're still mostly spending our time processing the data, writing up papers, putting together reports. Part of the reason why we haven't mapped out the future very specifically yet is because the project remains at this stage still a year-to-year project in terms of its funding. Some activities are funded for multiple years, but not a lot, and so we're sort of open to what the next summer will be about, and still defining that. On the other hand, we can afford to have this last-minuteness to it a little bit because we have the infrastructure in place already. So, we have our fleet of vehicles, we have a base camp. I mean, most people who plan a field campaign want to do this, at least a year ahead of time because they have to bring their own supplies, they have to bring their own shelters. That's quite a bit of logistics. At this point, we have all this in place. And so I tend to think of Devon Island now as sort of my field lab, or our field lab, where it's out there already, it's like a ground station. It's turnkey a little bit. And so, but over the next few weeks and months, I would say between now and March, we're going to be defining what the next season will be about. And then we'll know, by spring for sure.
I would love, my next question is what some of your broader future goals are. I would love to see a small autonomous ATV-sized rover that mates up to that new spacesuit that I hope you're going to get fairly soon. Which would be great. That's a big R&D project, and obviously something that would need some external help, maybe a university consortium or something. But that would be very cool. What else do you have in mind? Looking ahead.
Yeah, one of our research partners since the year 2000, every summer has been the spacesuit development team at Collins Aerospace now. I mean, they used to be called Hamilton Sundstrand. They made the life support systems and for the spacesuit on Apollo and of course the EMU on Shuttle and ISS. And then thankfully NASA had the wisdom of contracting Collins Aerospace among its spacesuit contractors here for future EVA systems. So Collins is going to be providing a new analog suit, we hope, in time for next summer. But what I would like to see happen as well is some measure of astronaut training, because I think that astronauts will have to obviously train in places that are, at domestic locations, more easy to get to, and they really need a diversity of experience. But if they're looking at longer exploration experiences on the moon, like longer road trips, even unpressurized, or if they're looking at doing, of course, Mars planning, I don't think a lot of places will prepare them as well as Devon Island would. It's it's an incredible place. And I want to emphasize also the lunar relevance of the place. I mean, you have an impact crater. There are impact craters on the moon, of course. Shackleton Crater at the south pole of the moon is about 20 kilometers in size and diameter. So it's actually the size of Haughton Crater. And by going to Haughton, you really get a sense of the scale of exploring a crater of this size, the types of, boulders that are sitting on the rim of Shackleton can be visited at Haughton as well. It's really, and then of course we are really engaged in the science of this place. It's not like we're going to Arizona where, the geology is fully understood now, and compared to Devon Island at least, and where you're sort of pretending you are advancing the science of Arizona while you're doing your EVA simulation. No, here you're going to Devon Island, you're really engaged in the science of this place. You're trying to understand the history of this crater, what happened, how it modified. We don't have, a very good understanding of how larger impact craters form yet. The dynamics are very complicated. What happens to the earth rocks are complicated. What happens to the impactor is complicated. So these types of complexities you don't run into when you visit a small crater like Meteor Crater in Arizona, for example. So that's not to diss Meteor Crater at all. We should, of course, do that. That's a very beautiful and important site for training. But we should, it's less relevant than to Shackleton, for example, exploring large craters of the south pole of the moon than going to Devon Island.
Well, to that end, Elon Musk wants to build a city on Mars. Pascal, do you see a city on Devon Island as that astronaut training center for those future explorers to go to the moon, to go to the Mars or whatever? Would you want to see that size of a base from the Haughton-Mars Project now, what it is now?
So the short answer is no. And here's why. I mean, I'm actually a fan of Elon's in many ways, but I also put the brakes on some specific aspects of his dream, because I'm not in favor of a large population being on Mars or some giant city. I'm not saying that it won't happen, but it's not something that is likely to happen anytime soon. But more importantly, I'm not sure that it's even desirable. I tend to think of our future on the moon and Mars, but the moon might be different because it's really close to the Earth. But for Mars, as long as it's many months away of travel, I tend to think of it as a place where for a long, long time it will be a bit like Antarctica. And models of Mars development, and using the Antarctic as an analog, are somewhat fraught with misconceptions. But what I see on Mars in the future are one or multiple research bases, an international presence, of course, and even some measure of tourism, just like we have in Antarctica. I mean, in Antarctica, we have shiploads of tourists going there each year, just like a starship, this vision of bringing 100 people from the Earth to Mars. I find that okay. And where would they go on Mars? Well, they would go to some sort of a resort, the Epcot of Mars that I can figure, where people would spend a few weeks having a lot of fun in Martian gravity, swimming. I promised Rod a paper on water sports on the moon
for the
Mars.
magazine, yes,
for the magazine. But imagine diving boards in 0.38 G and all kinds of things that you could do in a low gravity environment. Of course, now you're talking about being in a gym or a sort of a pressurized shelter. So that's what this tourism facility could be. And of course, you take the train ride to the edge of the canyon. You'd get some training on EVA, and you would do an EVA. But as Mike Gernhardt says himself, EVAs are an honor but not a pleasure, at least after a certain amount of time, because past the wonder of course, being on the EVA, it's actually quite strenuous and not really comfortable. And after a few spacewalks on Mars, it's going to get old, just like everything else. So I think there's going to be a real possibility for tourism, and of course, people who will go will be people who are very wealthy or very lucky, who might win at a lottery and get a ticket to Mars. So I see this combination of science and tourism being quite realistic, just like it is in Antarctica. But having a giant city with 1 million people on Mars, I like I said, I don't even find that desirable. I tend to want to think of Mars as a sort of a global national park, so to speak, that we would preserve posterity and really explore in depth. And hopefully by the time we actually could build a city on Mars, we'll actually be farther along with interstellar travel, and we'll go to places that are already habitable, as opposed to, wasting time and money terraforming Mars, which is another red herring.
Well, I have many more questions, but we're kind of short on time, so we'll have you back so I can ask those. But I want to thank you for coming, and personally, I want to thank you for having me as your most perplexing experiment for the 2022 field season. It was great fun coming, and I have to say, of the many places I've been that I guess one would consider possible Mars analog sites, including, Utah and Arizona and other spots, the experience this summer was truly extraordinary, and you really come home feeling like, other than I didn't have to wear a heavy pressure suit, thank God. I didn't have to worry about frying levels of radiation. I didn't have to worry about life support. I just had to worry about enjoying it. And you come home really feeling like you've spent some time on the red planet. So my great thanks for allowing that to happen.
I have to say, Rod really performed incredibly well as a field participant. Never a complaint. Always go. You were very well adapted up there, and I don't take this for granted, because some years we have participants, who realize how uncomfortable, if not harsh, Devon Island and a whole summer up there can be, and none of that stopped you from performing at 100% and writing about our stories. That was really great, Rod. So thank you.
Well, it was great fun. So thanks for coming. Thanks everyone for welcoming Pascal to the show. Pascal, as we always ask, we'd like to have you tell us where we can follow the work of you personally, HMP, and the Mars Institute.
Yeah, thank you. So we have a website, Mars Institute, marsinstitute.net or .info. Actually, .no as well.
Yeah.
marsinstitute.no. That's easier. I'm also with the SETI Intsitute, SETI.org, which also is a nonprofit. And then the Haughton-Mars Project itself has a website. It's marsonearth.org, marsonearth.org. The one and only Mars on Earth, really.
And you can also dig it up at the NASA website. They've got pages linked to your project as well.
Yeah. I have this hope that more people will be able to see and experience Devon Island at least once in their life. It's an incredible place. It's not just a piece of the Arctic, or it's like another world on our planet.
Absolutely.
And it's a very powerful experience to go up there. And I think people who have had a chance to go up there, understand what I'm talking about here. So we're always on the lookout for students who might have a research project, who want to work with us, to sort of contact us. You can do this through our website, marsonearth.org, or scientists who have an interest in this location. I mentioned the crater, but there's also the canyons, the valleys. The whole landscape is so Mars-like. It's an incredible place for research as well, for life in the extreme. I welcome new interest in this place, and we will do everything we can to make your dream happen.
You hear that, Tariq?
I do. I hear that. That sounds great. That sounds like a wonderful place.
Yeah, you should take a month off from space.com and join us next time.
It's really different.
He laughs. Tariq, where can we look after you?
As always, you can find me at space.com. On Twitter, I am at Tariq J. Malik. The J stands for just awesome, by the way. This weekend, if everything goes according to plan, this weekend you will find me getting my purple belt in Taekwondo, where I'm going to kick some.
Oh wow!
So hopefully, I can break some boards with my foot and not my
Respect.
foot. I will let you know next week. So.
For Tariq, just adequate Malik. All right. And you can always track me on the not frequently updated pylebooks.com, which I'm going to look after this week, I promise, or at astromagazine.com, or Facebook, Twitter, and occasionally at Instagram when I get around to it. Don't forget to drop us a line at twis@twit.tv. That's TWIS at twit.tv. We welcome your comments, suggestions, ideas, and jokes. More jokes, please. And thanks for joining us for our discussion with Pascal, who I like to call Master P. because it just seems to fit. Don't forget, new episodes published every Friday on your favorite podcatcher, so make sure to subscribe and tell your friends, all your friends, and even people that aren't your friends. And give us some reviews. We'll take 5 stars or a thumbs up, or you can stick out your tongue, whatever you want.
5
stars,
head to our
website
thumbs up
as well. Yeah, I agree.
up.
And you can always head to our website at twit.tv/TWIS. You can follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook and twit.tv on Instagram. Thanks very much, and we will see you next week.
Listeners of this program get an ad-free version if they're members of Club Twit. $7 a month gives you ad-free versions of all of our shows, plus membership in the Club Twit Discord, a great clubhouse for Twit listeners. And finally, the Twit Plus feed with shows like Stacy's Book Club, The Untitled Linux Show, The Giz Fizz, and more. Go to twit.tv/clubtwit. And thanks for your support.